All right, the next piece I'm going to do, and I'll probably break this into 3 separate individual videos, but I'm going to look through each of these 3 problems. Now you'll notice this is integral 8 over x squared plus 16 dx. Here the integrand is 8x over x squared plus 16, and here it's 8x squared over x squared plus 16. Each of these requires a different procedure. That's what's going to happen. We're going to start to talk about the techniques of integration. Chapter 8 is techniques of integration. It's one of the bedrock fundamental, any good, as far as I know, any decent Calculus 2 course anywhere has the techniques of integration. Of course, I'm not going to count this as a technique, but you know the basic forms. So assuming we know the basic forms, the techniques of integration are basic U substitution, which you know already, integration by parts, trigonometric reduction, trig substitution, and then the last is partial fractions. So those are the basic trigonometric, the basic techniques of integration, the basic techniques of integration that any good Calculus 2 course has. And I'll see if I can, it might not be a good one, but at least it's an adequate one here. We'll talk through these various procedures. Each of these 3 can be done with Calculus 1 techniques, which means at the very most it's going to require U substitution. But you'll see that each integrand, they're all different. This has 8, this has 8x, this has 8x squared in the numerator. So the question is, how does each of these go? That's another piece of the puzzle. Not only do you need to know all the techniques, you need to know how to use all the tools, you need to know what kind of problem requires this particular technique. What kind of problem requires this particular tool? It is not enough to have the tools in your toolbox. You need to know when each tool is appropriate to use, how to look at a problem, and sort through in your mind what you think is the appropriate technique. All right? Among other things, one of the things that helps more than anything else is practice. If you practice, practice makes permanent. If you practice enough, then as you see problems, it is within your realm of experience. This stuff that we're going to be talking about is not so much difficult, although there's a little touch of that. It's not so much that it's difficult. It is that it's unfamiliar. It's unfamiliar to you. And the way to get over being unfamiliar is not to watch me do 3 or 4 problems on a couple of videos. The way to get over being unfamiliar is you need to work through the homework and then try each of them. And if it works, fine, then internalize that. If you run into some problems, then you can ask me and we'll work through some of those together. So what I'm going to do now is I'm going to work through each of these 3, just to sort of have a practice of getting the cobwebs off your brain a little bit. I'm going to, and I'm going to probably break this into 3 little videos. Otherwise, they'll get a little bit too long for each of these 3 items. So here's number 1. What you need to see is, first off, is it clear we can move this 8 multiplier out front if we need to? What you need to see is, this is the tangent inverse form. You need to know the tangent inverse form. You need to know the tangent inverse form, recognize it when it arises, and then know what to do with it when it does. So this is the tangent inverse form. If you have a constant over the sum of squares, constant over the sum of squares, this is the tangent inverse form. What we need to do is account for what is u and what is a. This constant multiplier is just coming along for the ride, right? So if this is going to be the tangent inverse form, then we need to account for u, and we need to account for a, and we need to account for the differential. All right? So, what is the variable expression that's getting squared? What variable expression is getting squared here? The variable expression getting squared is x. All right? What is the constant that's getting squared here? What constant gets squared to produce 16? And we're going to use 4. If you look in the work you did in Calc 1, we assume a is non-negative. So a is 4. And then once we have u is equal to x, then we take the derivative of both sides. Du is dx. And now the substitution is exact. so that when we substitute, I'm going to kind of steal some space here. I'm going to take this 8 and put it out front of the integral, and which leaves me as 1 over. Instead of x squared, I'm going to write that as u squared. Instead of 16, I'm going to write that as a squared. And dx becomes du. This now is precisely the tangent inverse form. Now, what do we know the tangent inverse form to work out to be? 1 over a, tangent inverse, u over a, plus the constant. Right? So that's the tangent inverse form, where a, in this case, is 4. So all we do here is we have 8 constant multiplier out front, multiplied by, this is 1 over a, tangent inverse of u over a, plus the constant. And now let's translate back to the original expression and simplify as we go. A for our problem is 4. So what we have is 8 times 1 over 4 tangent inverse of, what's u in our problem? U in our problem is x over 4. And 8 over 4 is 2. So we can write that. The final result is 2 tangent inverse x over 4 plus the constant. We're out. So that should all be within your comfort zone. It might be a little fast there, but it's something that you would have been able to do, hopefully, in Calculus 1. All right? So work through that. Pause that if you need to. Make sure that's part of your comfort zone. And then the next piece we'll do is we'll work through with the 8x over x squared plus 16.